You've got $20 in your pocket and you're heading to the movies. A ticket costs some amount, call it X. After buying one ticket, how much money do you have left? That little expression, 20 minus X, is powerful. If tickets cost $8, you have 12 left. If they cost 15, you have 5 left. Same expression, different values depending on X. That's exactly what we're going to master today. How to evaluate expressions, how to spot their parts, and how to turn everyday sentences into algebra. Let's start with evaluating. To evaluate an algebraic expression means to find its value when we replace the variable with a specific number. Substitute, then simplify using the order of operations. That's the whole game. Try this one with me. Evaluate x plus 7 when x equals 3. We swap x for 3, giving us 3 plus 7, which equals 10. Now what if x equals 12 instead? Then it's 12 plus 7, which is 19. Same expression, two different answers, because the value of x changed. Let's try something a bit trickier. Evaluate 9x minus 2 when x equals 5. Remember, 9x means 9 times x. So we substitute 5 in, giving us 9 times 5 minus 2. 9 times 5 is 45. And 45 minus 2 is 43. Now, what about exponents? Evaluate x squared when x equals 10. Careful here, x squared means x times x, not x times 2. So we get 10 times 10, which is 100. And one more twist. What if the variable is the exponent? Evaluate 2 to the x when x equals 5. Now we have 2 to the 5th power. That's 2 times 2 times 2 times 2 times 2. Let's build it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Let's tackle an expression with two variables. Evaluate 3x plus 4y minus 6 when x equals 10 and y equals 2. Two substitutions this time. Substitute both values, 3 times 10 plus 4 times 2 minus 6. Order of operations says multiply before adding or subtracting. So, 3 times 10 is 30. 4 times 2 is 8. That gives us 30 plus 8 minus 6. Left to right, 30 plus 8 is 38, minus 6 is 32. Done. Pause the video and try this one yourself. Evaluate 8x minus 3 when x equals 2. I'll wait. You should have gotten 8 times 2 minus 3, which is 16 minus 3, which is 13. Nice work. Now let's zoom out and look at the parts of an expression. Every algebraic expression is built from terms. A term is either a constant, like 7, or a constant times variables, like 9a or 5x squared. The number in front of the variable is called the coefficient. In 9a, the coefficient is 9. In 5x squared, the coefficient is 5. And here's a sneaky one for just plain y. The coefficient is 1, because y means 1 times y. Let's identify the terms in this expression. 9b plus 15x squared plus a plus 6. For terms. Their coefficients? 9 for 9b, 15 for 15x squared, then 1 for a hidden 1, and 6 for the constant 6. Now, some terms are like terms. Like terms have the same variables raised to the same exponents. All plain constants are like terms with each other. Look at this list. 5x, 7, x squared, 4, 3x, 9x squared. Which ones match up? 7 and 4 are like terms, both constants. 5x and 3x are like terms, both have plain x. And x squared and 9x squared are like terms, both have x squared. The exponent has to match exactly. Why do like terms matter? Because we can combine them to simplify. If you have 3x and you add 6x, you get 9x. The same way 3 apples plus 6 apples is 9 apples. Let's simplify a longer one. 3x plus 7 plus 4x plus 5. Step 1. Identify like terms. 3x and 4x go together. 7 and 5 go together. Step 2. Rearrange so like terms sit next to each other. That gives us 3x plus 4x plus 7 plus 5. Step 3. Add the coefficients. 3x plus 4x is 7x. 7 plus 5 is 12. Final answer, 7x plus 12. Simplifying is powerful, but expressions don't usually arrive already written in math. They arrive as words. So we need to be able to translate. Certain words are signals. Some and more than mean add. Difference and less than mean subtract. Product and times mean multiply. Quotient and divided by mean divide. Try this. The difference of 20 and 4. Difference means subtract, so it's 20 minus 4. Or the quotient of 10x and 3. Quotient means divide, so 10x divided by 3, which we can also write as the fraction 10x over 3. Here's where students trip up. 7 less than 9z. Sounds like it should be 7 minus 9z, right? But less than flips the order. It means 7 is being taken away from 9z. So the answer is 9z minus 7. And parentheses matter more than you think. Compare these two, 5 times the sum of m and n versus the sum of 5 times m and n. In the first, we add first, then multiply the whole thing by 5, so it's 5 times the quantity m plus n. In the second, only m gets multiplied by 5 before we add n. That's 5m plus n. Same words, different order, totally different expression. One more, a real setup. The height of a rectangular window is 6 inches less than the width. Let W represent the width. What's the expression for the height? 6 less than the width means we subtract 6 from W. Height equals W minus 6. You just learned how to breathe life into an expression by substituting values, how to name every piece of it, how to combine like terms, and how to translate everyday words into algebra. Next time, what happens when two expressions are set equal to each other, and how do we find the mystery value that makes them balance?